Hello everyone, my name is Ogenetiju Omamogo and you are welcome to Oxchem Academy. Now if you are new to my channel, feel free to hit the subscription button below. Also like, share and of course avail yourself to this lesson so as not to be left behind. Welcome back. So in today's lesson, we are going to be talking about the constituents of an atom under the broader topic, particulate nature of matter. So we began particulate of matter series in our last two lessons. So if you are yet to check out that video, please do well to do so in my channel. It is titled Particulate Nature of Matter, Physical and Chemical Change, and also Particulate Nature of Matter, Dalton's Atomic Theory. So we're going to be talking about particulate nature of matter under the subtopic constituents of an atom, which is your proton, your neutron, and your electrons. So first things first, if you can recall, we said that an atom is the smallest particle of an element which can take part in chemical reaction. Under our teachings on John Dalton's atomic theory, we learned that atoms are no longer indivisible. They can now be divided into what subatomic particles, which we now know as protons, neutrons, and electrons. So we're going to be quickly defining what these subatomic particles are, and I hope we'll be able to understand. So first things first, protons. What are protons? Protons are also known as positively charged ions. Okay, so they carry a positive charge. That is what protons are. They are called, or they are referred to as positively charged ions. So for our neutrons, neutrons are neutral in charge, meaning that they carry zero charge, they carry no charge at all. Okay, so they are neutral in charge. Then for our electrons are negatively charged ions. So electrons are negatively charged ions. They carry a negative charge. So very quickly, we want to be defining what electron configuration is. Electron configuration can be defined as the arrangement of electrons around the nucleus of an atom. So electron configuration can be defined as the arrangement of electrons around the nucleus of an atom. Electron configuration is, we're going to be taking some few examples on how to arrange electrons around the nucleus of an atom using our elements as examples. So, example 1. We just defined electron configuration, arrangement of electrons around the nucleus of an atom. So, in the arrangement of electrons around the nucleus of an atom, we're going to be explaining how electrons are actually arranged. So, we have the first shell, the second shell, the third shell, fourth shell. Okay, so in the first shell, what you need to understand is that it can only accommodate a maximum of 2 electrons. Maximum means that is the most amount of electrons that can be in that shell. Okay, so the first shell can only accommodate a maximum of 2 electrons. Then for your second shell, it can only accommodate a maximum of 8 electrons. So meaning that after 8 electrons, that shell is occupied. Then for your third, fourth, and fifth shells to infinity, they can also accommodate a maximum of 8 shells. I hope you understand that. So the first shell is 2, the second shell is 8, the third shell is 8, the fourth shell is 8 till infinity. So that's what we mean by maximum. Maximum means that is the maximum amount of electrons that can be on that shell. So I'm going to be taking some examples so that we can better understand electron filling in an orbital. Example, we're going to be taking carbon. Now, carbon has an atomic number of 6, and we're going to be demonstrating how these electrons can be filled around the orbital. So, just follow along to understand. So, the first thing you do is to draw your first shell. Now, like I formally explained, your first shell can only accommodate a maximum of 2 electrons. So you place your 2 electrons as so, 1, 2. So that is the maximum that can be on the first shell. So if you do your subtraction, 2 minus 6, you know that we have 4 electrons here. So where do we place the 4? Do we put it here? No, we do not. Why? Because the first shell can only accommodate a maximum of 2 electrons. So any other electrons left must be moved over to the second shell. So we draw our second shell. So we have 4 electrons left out of 6. So 1, 2, 3, 4. So if you count the electrons on this shell, we have 1, 2, 3, 4, 5, 6. So it is complete. So the electron configuration of this element carbon is 2,4 configuration. I hope you understand. So we're going to take another example so that we better understand what I'm trying to explain. Sodium. Now, sodium has an atomic number of 11. So let's see how we can do this. So, like I said, you draw your first shell. Your first shell can only accommodate a maximum of 2 electrons. So 1, 2. If you subtract 2 from 11, what you have left is what? 9. Yes, 9. So what do we do with the 9? Do we add it to the first shell? No. The first shell can only accommodate 2 electrons. So we draw the second shell. So bear in mind that we have 9 electrons that we have to place in the shell. So we fill 1, 2, 3, 4, 5, 6, 7, 8. Now, why do we have 8 on the second shell? Remember, I said when we are filling in our electrons, the first shell can only accommodate a maximum of 2. The second shell can accommodate what? A maximum of 8. So 8 electrons can be placed in the second shell. So if you count, we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 electrons on the second shell. But 8 plus 2 is 10 and not 11. So meaning that 1 electron is left. So what do we do with that 1 electron? We place it on the second shell? No. The second shell can only accommodate a maximum of what? 8 electrons. So what do? We move the leftover shell, the leftover electron, to the third shell, and then we place it at the top. So this is the electron configuration of sodium. So we have 2, 8, 1 configuration. I hope you understand. So I'm going to be dropping some examples on the board, pause the video and attempt to do it on your own, and then play to see if your answer is correct. Now, if you have solved the question on the board, let's do our correction together. So, aluminium has an atomic number of 13. So, like I said, our first shell can accommodate 2 electrons. Our second shell can accommodate 8. So, if you count, what you have is 10, remaining 3. So, the 3 must be moved over to the third shell because the second shell can only accommodate 8. So, you place the 3 as so. So this is the electronic configuration of aluminium, 2, 8, 3. So you can also do the same for zinc. Zinc has an atomic number of 30. So you can do the same for zinc. So take this as a class exercise. Do the same for zinc. Do the same for calcium. And of course do the same for fluorine. So do these examples and then you'll be able to determine whether you actually understand this topic. If there is any confusion, please feel free to drop it in the question below. If you have questions, comments as regards this topic, also feel free to drop in a question below. But for the sake of those that may want to ask this question, now you may want to know, why do we pair the electrons? Why not just place them anyhow? No, chemistry is all about principles and laws. We have what we call Hund's rule. Okay, so Hund's rule states that electrons must be paired singly. Singly means one at a time before pairing can take place. Okay, so you must first fill the electrons one at a time before you start to pair. So in chemistry, everything is done intentionally. Okay, so we are obeying principles in filling up the electrons of this atomic number. So with that, we bring the class to a close.